So some other application of operation amplifier is precision diode. This is also called a super diode. So in general, silicon or germanium diode, whenever we use it, start conduction or it comes in a on state when the voltage drop across the diode is 0.7 volt in case of silicon and 0.3 volt in case of germanium diode. And this voltage is called knee or cut-in voltage. So first, if we look about this circuit where we have a operation amplifier, we have input in non-inverting terminal, that is positive side, and we have a negative feedback, and we have one diode in the operation amplifier. The output voltage is represented by V0 and the voltage at output of op-amp is represented by V0 dash. So if we take D as a short circuit, that means if D is short circuit, so we have V0 equal to Vi, that means the circuit works as a voltage follower circuit. Only if D is short circuit or is on state. If we consider or if we take V0 is the voltage at this side, that means V0 dash is a, if we consider V0 dash is equal to open loop gain. So in case of operation amplifier, we know that the open loop gain V0 dash equal to AOL multiplied by Vi, where AOL is open loop gain and Vi is the input signal. So these points are clear. Now we will take two conditions of V0 dash as written here. We look that V0 dash is equal to AOL multiplied by Vi, where AOL is equal to open loop gain. And we know that in ideal case open loop gain equal to infinite, and but in practical operation amplifier the open loop gain is very high. So if we took the first condition, if V0 dash is less than 0, if V0 dash is less than 0, then this diode D will be in off state because it will not get the sufficient voltage to come in the conduction state. So it will be in off state. So this will be open circuit and we will get V0 equal to 0 as it is written here. If V0 dash is less than 0, then diode D is in off state and V0 equal to 0 volt. The second condition is if V0 dash is greater than 0. So if V0 dash, this voltage is greater than 0, then the diode D is in on state and we get V0 equal to Vi, that is it work as a voltage follower circuit. So the same thing is written here, V0 dash is greater than 0, diode D is in on state and V0 is equal to plus Vi. Now we will discuss about this second condition in more detail. That means V0 dash is greater than 0. So V0 dash is greater than 0 means we know that V0 dash is equal to AOL multiplied by Vi. So it means AOL Vi is greater than 0. So we can write it as Vi is greater than 0 upon AOL. So in ideal operation amplifier, AOL equal to infinite. So we can write Vi is greater than 0 in ideal operation amplifier to come D in on state or on conduction state. But this is true for only for ideal operation amplifier where we consider AOL equal to infinite. We know that in practically case V0 dash means we must have at least knee voltage at V0 dash to make diode is in conduction state. So for practically we know that V0 dash must greater than V gamma, which is cut-in voltage. So Vi, we can write V0 dash equal to AOL multiplied by Vi, and we can write it as Vi is greater than V gamma upon AOL. So practically AOL is not equal to infinite, but it is a very high voltage. And generally V gamma is equal to 0.7 volt for silicon and 0.3 volt for germanium. So the value of Vi must equal to zero point 0.1 greater than Vi is must greater than zero point 0.1 volt practical value. So diode D will come in on state when Vi is greater than 0.1 volt or just above the zero due to high gain of operation amplifier. So in ideal case, to make diode D in conduction state, to make diode D in on state, we must have Vi is greater than 0. But practically, Vi must equal to or greater than zero point 0.1 volt to make diode D in on state. When we use normal silicon or German diode without using operation amplifier, that the voltage required to make diode in on state is zero point 0.7 volt or zero point 0.3 volt in case of germanium. But here in with this particular or with this operation amplifier, we required only Vi is greater than 0.1 to make D is in on state. So this type of configuration or this type of diode is called precision diode, and it is also called super diode. It minimizes the wastage of input voltage, and we can make the half wave and full wave rectifier circuit by using precision diode, and some other circuit by using precision diode instead of normal diode.